everything that's going on. But just to kind of share some dates with everyone on some topics that are, I apologize here. I flipped the slide, but it didn't move. There we go. Some topics and dates and times of some other Comet Academy classes. They're Tuesdays and Thursdays right now, every week. Coming up on Thursday would be the review of common NFPA and OSHA requirements for spray booth design. So, if any of these topics interest you, make sure that you get registered for those. We'll have some more coming down the line. But today, right now, this afternoon, let's go ahead and talk about filter selection and a review of a case study. Again, my name is Trey Peavy, and I'm the product manager of RP Filtration Products here at Comet. So in case you're not real familiar with Comet and who Comet is, just got a couple of slides here to bring you up to speed, hopefully. But we do all of our manufacturing in Rockwall, Texas. And in our facility there's a nice picture of it. Just shows you the front corner. All of our manufacturing is done there. And inside of our manufacturing, we break our business segments up into just three different. Our business is broken up into three different segments, we could say. So our first segment is our core and catalog equipment, which is spray booths, powder booths, batch ovens, things that are of a certain size and design, and they're in a catalog, right? And those just go out. They fit a lot of the application needs out there. And then we also have a more engineered side, which is our engineered projects or engineered products group, which is going to handle things more along the lines of inline conveyor systems, washers, custom booths of some nature. They just require some more engineering. So we have those two segments that are for our sheet metal, and then we have our third segment, which is our RP filtration. So to kind of go through what the RP filtration is. So in mid-2017, Comet acquired the paint arrestor division of research products. So that is where the RP came from here when we say RP filtration. Research Products had a great brand name. They were obviously the inventor of the slit expanded paper line of filtration. And because, they just had a great name in the market, we elected to keep the RP designation to make that transition. So if you're wondering what is RP, that's exactly what that means. So considerations for filter selection, right? There's a lot of things that go into it, and there's a lot of different filters and filter types out there. So right now, Comet manufactures slit and expanded paper. So we're going to mostly focus on that. We're not going to get too extremely in depth. We will talk about some other types of filtration and their uses and kind of their characteristics. But we do have a limited time together today. So I'm just trying to hit the core things that we need to, work towards. So to identify the correct filtration for a project, we need to know a couple things. And one, we need to understand what issues are that are presented to us that need to be overcome. We need to understand what filter type and design is going to solve these issues. And then we need to place that filtration into production. That would be like a filter trial. And then hopefully, if everything has worked right through that filter trial, then we're going to generate a success story. And success stories are easy to build on. They're easy to sell future projects. When we have successes and we know that filtration works in certain instances, it just makes the selling process that much easier. So let's go ahead and we'll kind of dive into those four things. To understand the issues that need to be overcome is we really need to understand what the customer is trying to accomplish. So maybe the customer is needing higher efficiency. Perhaps they've changed their coating type and they have a lot more hazardous type of coating. They can't afford to get that overspray out into the atmosphere or in the environment. Perhaps they just went through a very costly fan change out where they had to clean out everything, and they've realized, it's a little more cost for the filter, but it's not near as costly as what it took me to shut down my production, have maintenance personnel, pull fans down, get rental equipment, and and et cetera, and et cetera. So that may be what the customer is looking for. It's possible that the customer is looking for a longer production time. In the filter world, we're all hoping for that guy that needs just one more hour to get them to lunch. before they have to make a filter change so they don't have to put gaps in their line, right? But they may be trying to get a day. They may be trying to get 2 days or a week or possibly a month out of a set of filters. So we just need to understand, is that what they're trying to accomplish? Now, everybody right now is thinking, how do I lower costs, especially with everything that's going on in our economy, with the COVID shelter in place things, and it's just kind of slowed everything down slightly to a grind almost. But someone's trying to figure out how to lower filter costs. So that may be what it is, right? They're just, hey, we're using this filter. We just looking, can we lower that? Now, filter cost is not just necessarily the price of the filter. It could also mean that I have increased the longevity of that filter in the production time, and that in turn would lower the overall filter cost versus what they're using now. So filter cost isn't necessarily just the price of the filter, and there's a couple other things, and we'll kind of talk about that some here in a little bit. They may just be wanting better airflow in their booth. Possibly they bought a spray booth that was just a kind of a standard booth for a hobbyist type booth or something like that. They put it into an environment where the production is a little more demanding than what it was maybe designed for. And then maybe they're using some filters that are very high efficient, and high efficient filters a lot of times bring high initial resistance. So it's harder for the air to move through that filter because it is more efficient. So possibly that's creating airflow problems inside of their booth, to where maybe they're just not capturing all the overspray and it's flying around in the booth. Perhaps after they spray for a short amount of time, the booth becomes positive, things like that, and that may be something that they're trying to overcome. And maybe they're just trying to fill that hole. They've been spraying outside, they've been spraying without a spray booth, and the authority having the jurisdiction come in and said, well, guys, y'all got to get a spray booth. And those guys a lot of times just say, you know what, I don't care what it is. This is dumb. I got to do this. I've been doing this for 20 years, and we've all kind of had those instances. So maybe that's it. And we just need to understand what the customer expects from us to help them with their solution. Some other important information that probably I'm going to ask you, especially if you come to me and say, Trey, what do you think? Is I'm going to want to know how much coating are they spraying? Now, that can be daily, weekly, whatever. We can always kind of, do the math to figure out what we're seeing. And then what is the coating? Because those two things do play a big part in our selection of filters, okay? So when we talk about selecting filters, we really need to be able to understand what the filter types and the different designs and how will they solve the problems and what's their characteristics. So any type of filter, regardless of a paper, a fiberglass, or a polyester, all have performance characteristics, right? And they all have a certain holding capacity. They all are going to create a certain pressure drop initially, and then they're all going to, have a certain capture efficiency, right, or an arrestance percentage. So a lot of factors, though, that'll play into the performance of a particular filter. You may have a filter that performs one way in one application, and it's going to perform differently in another. And a lot of that is due to, like I say, the type of spray booth there is, the booth design and the air velocity. So if it's a cross draft or a downdraft, if you visualize a cross draft booth where you have an exhaust chamber on one end of the booth, and let's say you have a filter section or an intake filter section on the opposite end of the booth, where our airflow is moving predominantly horizontal, then that's going to change our performance of our filter versus if we were in a downdraft configuration, because eventually gravity overtakes the overspray particulate and it's going to set some on the ground in both of those instances. But in a cross draft, it's likely it's just going to sit on the ground and never reach our filter face. In a downdraft, it's going to land in our filter media, right? Even if we didn't pull it in with airflow, even if gravity has forced it to the ground. So that filter is actually going to catch more paint in a downdraft configuration than it would in a cross draft. So it may not get the same amount of production longevity that you saw in a cross draft, right? So those things are important to know. The coating materials, right? If we're spraying a urethane coating, which has a great tendency to like to face load and clog up filters, or, versus spraying something that's a little more dry, so we're spraying a lacquer or something like that, then we're seeing something that's a little more dry versus something that's a lot wetter. Those filters are going to perform differently. Even the application equipment applies to this. If you were in our presentation webinar that we did last Tuesday, we touched on this a little bit when we were talking about the principles of filtration and how a filter actually works and performs. So if we had, say, a rotary bell atomizer in a booth, it is spraying a lot finer particulate as an average across the particulate curve than what an HVLP gun would be spraying. If we're spraying something that is, say, a clear coat that's easily sheared, then those particulate sizes are even smaller. So knowing the type of application equipment and the coating, again, has changed possibly the way our filter performs. Operators have a big impact on filters, not only from the case of, hey, let me get my gun cleaned out, or let me get my gun spraying well, I'll just spray right into the filter face from 2 inches away, or they're not very efficient. Possibly, they're not using electrostatic. They have a lot of blow-by when they're painting parts or something like that. The pressures are too high. So a lot of that has to do with it, where you go to one customer that has really good paint operators, and you go to another one that's not quite as efficient. So, your filter is seeing more overspray in the same amount of time as it was there because their transfer efficiency wasn't the same, right? And again, distance from that spray application. I kind of mentioned that when our human applicators like to, spray the gun right into the filter to get it set right. But in some chain on edge situations, you may have an automatic gun that's spraying just a couple of feet from the filter face. Obviously, that filter is going to perform differently than one where our application is 5, 6, 7, or 8, or even longer from there. So even if it is the same type of coating, it can perform differently. So all those things kind of play into it. And like I say, we don't have the time together to go into depth into each one of those. I was hoping to give you guys a good basis through this. So I did mention the additional filtration methods out there. And I just threw kind of a chart together here. And what I'm doing is I'm just comparing the attributes across a Comet RP paper and polyester filter, which would be our 3200, 3300, 34, 36, and 3700s, or on our W series Premier line would be the W50, 51, and 5200. All of those are paper poly. And I'm just going to compare that against some polyester and then against fiberglass. Okay. So when we think about loading of a filter, the paper design lends itself very well to depth loading. Is where we use that front baffling of paper to catch those rocks and marbles, right, that of particulates that we're throwing at it, and it sticks into that paper. It doesn't get into our polyester, which is used to bring our efficiency up. So our filter is going to load sort of, in depth. We're going to start getting those fine particulates down and deep into the filter, and we're building those back out to the front to our larger particulates. Polyester and fiberglass have a tendency to face load or surface load. Okay, so it's just the way that the filter has been designed, where a polyester filter, even though we're using polyester in the RP, it doesn't have the paper baffling in front of it to catch those larger particulates. So what happens is that polyester is catching those marbles, those rocks, and those very small overspray particulates all on the face. Right now, there's different designs where they're more open, the denier changes and things like that. But typically across the board, polyester is going to face load. It is against a wet coating. Now, there are times where a polyester may be better than a straight RP filter in a very dry application, right? And then the paper doesn't play as huge of an impact in that as it would in polyester. Just want to be honest with you guys. Comet RP paper is not going to fit 100% of the applications to be the absolute best. Can it go in all those applications? Absolutely. Is it going to service 80 to 90% of the applications to be one of the top running types of filters? Absolutely. So the fiberglass, again, is going to see that face loading as well. On the holding capacity side, because we can depth load, our holding capacity on a paper polyester filter is heightened. So we're able to catch more paint without surface loading, without the filter being to the point that the fans can no longer move air through it. Polyester as a kind of a whole, you're going to see a low to medium holding capacity. In fiberglass, you're going to see about a medium holding capacity. And I get fiberglass a medium because there's a lot of ranges of fiberglass depending on the weights that you're running. And usually they do, hold a decent amount of paint before they load up, but they also let a lot of overspray go through them, so it kind of gives them the perception that they hold a lot. So on the efficiency side, the polyester and the Comet filtration are going to be about the same because we use the polyester to heighten our efficiency. We protect it with the paper so that we can get that longevity and get that depth loading, but you're going to see the efficiencies are still very high. Polyester, like I say, is running the same. And then your fiberglasses, again, depending on the type of fiberglass that you're seeing, a 15-gram fiberglass is going to perform very low against the high solids. Maybe they're getting close to 98% to meet the minimal guidance. But if you're not spraying that exact coating and an exact application, there is no way you're even coming close to a 90-something percent. You're probably down in around the 50s or 70s, just to lay it out there for you. But there are some fiberglasses out there that are a heavier weight, that some of them even have a small polyester backing on them. And those are seeing, closer to 99. The resistance, or the initial resistance, or how hard is it for the airflow to move through the filter. The Comet RP filters are very low. They're about 0.03 on an average with the polyester backing at 150 feet per minute. Where the polyester, you're going to see more of a medium to high resistance. So, if you think in terms of, say, like a paint pocket, which is a premier polyester filter, they run somewhere close to 0.08 to 0.1 inches of water column in a booth. So, what that means is they're right now already 70% more restrictive than what the RP filter is just initially out of the box. What that means for some applications is you can't run the filters as long because the fans don't have the ability to load the filter but to a certain point. So if you start out with a higher resistance, you just cut down on the longevity you can actually get out of that filter. Fiberglass, you're going to see resistance from low to medium, like once again, depending on the type of fiberglass you're going to see. Some of those fiberglasses are very low, like 0.01 inches of resistance. But once again, I can read a newspaper from the backside of those filters. On the cost side, your RP filters are, around the medium run. We're not the lowest cost solution out there, which would be the fiberglass. But you're not the most expensive, which a lot of times turns into just the polyester type filters. So you're going to see your cost ranges kind of running through that area right there. So to kind of talk to where the paper filter can be used and how the coatings work, like I said, Research Products, which was acquired by us in 2017, has 50 years of knowledge behind these filter models against different types of coatings and things like that. So I throw these up there to you. I urge you to pull the handouts down from the webinar because there's a lot of information here to look at, and then that way you can kind of get a starting point. And I say starting point because there's so many factors involved in what we talked about. What kind of booth is it? What's the application equipment? What is the application? What is happening? So, but what we've done with these charts is we kind of took a filter and we compared them against each other to say if we were spraying a certain coating, let's say a urethane, which would be a high viscosity coating, which would be the bottom in that top section. And we've compared them across the board to all of our filters. The 3000 and the 3100 filters are paper only. So there's no polyester backing. So you're going to see a slightly lower efficiency because of that. The 3100 has a higher efficiency because it has 8 layers of paper. And through all the layerings of paper, it filters out against the high solid, to get over the 98%. But the 3200, 3300, and so on all have that polyester backing. But as you move across to say like the 3700, that filter has two different types of polyester on the back of it. So therefore, its resistance to airflow is high, or definitely higher than the rest of them, right? Its efficiency is high, and it does have a good holding capacity because it is a high capacity paper system to hold a lot of paint. So looking through these charts, it gives us a starting point. If you look at the W series and we're still looking at the urethane, we would say, hey, a good starting spot to try out would be somewhere around the W5100, right? It's going to perform better than the 5000. The 5200 is going to outperform it in longevity because it is a high capacity version, right? So that's where it goes back to, what are we trying to get for our customer? Does a customer need better efficiency? Does a customer want more longevity, right? That is what we need to understand, and that helps us settle in to a lot of these different filters, because, guys, it's easy to go out there and sell filters just based 100% on price. Hey, this is competitor's A price, this is my price. Here's competitor's B price, this is my price. But a lot of times it doesn't just go down to that. We'll talk through it in our case study some, where maybe the filtration does cost more, but in the overall, it is, it's brought it down. So to move on to our next step is, once we've kind of determined what filter we need to start with, right, and we have a good idea of our application and our goals, then we need to run a filter trial. And then, in running that filter trial, we're just going to run the filter that we selected in our customer's application, right? And we're going to work to schedule the trial when the production load is normal. Running the trial, during fluctuations in production sometimes can hurt us. If the production is elevated, that's going to be unfavorable against our testing, right? Especially if we're trying to get more longevity in the production. If they only spray 10 gallons a day and we run our trial and they've ramped up and are spraying 20 or running multiple shifts and they haven't done that before, that can make our trial a little bit unfavorable. Right now, with everybody, it's kind of cooling back on production a little bit, to be honest with you. As far as sales technique, this is a great time to run trials if you can get, access into their plant, because they will be running less media than they were running before. And it just makes it perceive better, right? Not that we're going to lie on the testing results or our numbers, but it's just going to perceive better, right? So perception is, when what someone perceives is what they perceive to be true most of the time. But the main thing I can stress here is that when we run a trial, to be on site. So do not leave it up to the customer to run this trial. I don't know how many places I've walked into, and most customers don't even install the filters correctly. I've seen filters installed backwards. I've seen filters installed where they weren't cut long enough or something, and there's big gaps or holes in the filtration, right? We need to be there to make sure that everything is as it should be when we run these trials. Me personally, I like to be there one day, especially if the production allows it, where maybe they're changing out every day, which is really nice. But I like to be there one day while they're running their current filtration, or just show up right when it's about time to change. That way I can see what they've done with that kind of filtration. How's it performing? Then when we put ours in, we make sure that we either installed it correctly because they didn't have theirs installed right, or whatever, because we need to control this test as the person that's providing the solution. We don't want to leave it up to the customer. What happens is they throw the filters in, you come in there and go, hey guys, did it run longer? And they're like, well, I don't know, maybe. And the painter's like, well, yeah, I think it did. I don't know. It's about the same. But no one really knows. And they end up spraying more paint than they did the day before. And they forgot what day they put them in. And there's just a lot that goes on. So it is a little time consuming, but we need to be on site when we're doing these. If you need assistance, especially if we have a volume, customer here that we know that we can get some volume, I'm always willing to travel and help with these types of things. So what we have to do when our filters are in this trial is we have to measure that performance and how did we do? How did we compare to what was existing? Were we trying to get more efficient, or are we more efficient? Right? Ways to test for efficiency. I like to use a very high density polyester panel, and I put that behind one of my filtration cells or somewhere behind a blanket, and then I can measure how much paint is coming through. I also like to have that done with the current filtration, especially for we're working on the efficiency, right? Because we need to be able to show that we're catching more particulate, either through visual indicators or weigh the filters or whatever we have to do, right? So how do we compare? And are we meeting the requirements, to overcome what we needed to overcome for that customer? So, once again, it depends on what we're trying to do for that customer. But that's what the filter trial is all about. Hopefully we hit it on the first shot, right? We put the right filter in the right time. If we didn't, and we see that our filters aren't performing as we needed them, it's great because we're on site and we see that happening, and now we better understand what we need to do and what maybe type of filter we need to change to. Because guys, remember, you saw that list of all those different models of filters. So one paper filter isn't the answer to everything. Those models have all been generated to either meet certain price points in certain applications, or to meet certain efficiencies in certain applications, or to meet so much longevity in certain applications, right? So we have to work through those to see what's happening. If we see that our filters just doesn't have enough holding capacity to get what we need, then we know we need to go to something that can handle more holding capacity. But if we're there, we see those things happening, we let the customer know that, hey, we're here to get that solution for you. We're not done, because one size paper filter does not fit all. So just to kind of, if all that's successful, right, we get all that going on, then what you should do is be able to create a success story. And I like success stories because it's a way for me to tell you guys how to sell my product. People ask all the time, Trey, how do we know how to sell your product? What do we do? What do I need to teach my salespeople to go in and know how to sell your product? Well, stories like this one particular especially, is something that if they understand and they've heard or know, and they see this in the real world, then boom, they know that they have a solution, right? So let's go through this success story here right now. So what was happening here is this was a manufacturer for car hauling trailers, and they run a multi-shift operation. They were spraying a 2K urethane primer, and then they had a flash off right in between that primer and the top coat. And on the top coat, they were spraying a 2K automotive polyurethane with a electrostatic application, actually. Okay, so what their challenges was, and what the customer was trying to get over is I need more longevity. So what was happening is their filters were only running for 2 shifts, which is 1 day. So they run 2 8-hour shifts. And what they were seeing is, like, throughout the day, that the airflow would degrade, in the booth, as they were spraying. And then especially once they flashed off that urethane primer, it just kind of flattened out, turned into a big sheet of plastic almost across their filters. If you see the filtration to the right, that is the 16 hours, right? That is 40 gallons of paint sprayed in the booth. They had 3 operators, and that's what they were spraying was 40 gallons a day, 20 gallons a shift. These were operators that did not have the highest transfer efficiency, so the filtration was seeing a lot of overspray. But you can see from the images, that was the filtration wiped out on the surface after 16 hours. So what we did is we come in and we tested. Actually, I tested 4 different series of filters at this one customer's location. But what we kind of settled into was the W51. They were in blankets. It's a side downdraft booth. You can see from the images there. And what we did is I just measured the pressure resistance across the filters. We did that with their ode as well. Now, there's a couple ways to do that. You can use the manometer that's located on the exhaust chamber if it's been installed correctly, right? You have the high pressure port to the inside of the booth, the low pressure port behind the filter face before the fan, right? That's going to give you the resistance or pressure drop through the filter. I have a Dwyer digital manometer that I carry around with all the different little hoses and fittings and all that. And that's what I use. But like I say, the manometer on the side, as long as it's has enough fluid in it and it's level and it's installed correctly, is going to give you the same type of reading on resistance. But also measure the air velocity in the booth. I do that with a hot wire, and we can go through some things like that. But and then maybe another webinar we can go through some booth balancing and things and how to do that. But so we just measured all that. I measured how fast the fans were spinning and all of that kind of stuff so we could generate electrical cost and all of this. And what our result came out to be is the W series filter lasted for over 4 days. It actually runs now for 5 days, which would be, 10 shifts. But when we originally did this, they were running it for 4 days, and the operators noticed considerable difference in the booth. So what was kind of funny to me is while we were running these, and I would take different pressure readings every 45 minutes. That's how long it took them to spray a coating. Every 40 to 45 minutes, I would take all my pressure readings. And a guy come out of the booth, and I said, "Man, how you think it's going?" And he goes, "Oh, it's going really good." And I was like, "Well, okay, well, good." He goes, "Yeah, the way I know is because normally our observation window on our door has so much overspray on it, we can't see the end of the booth anymore." And this was around lunchtime. And I was like, "Really?" He goes, "Yeah, about this time of day, we can't see into the booth anymore." So we were making, already doing a better job, and honestly probably catching more coating than they were before because it wasn't sticking on the wall and it was going into our filters. But anyway, to move on, if you just took the filter usage, the reduced filter usage they would have to do, and their labor, which took the 3 guys about 40 minutes to change all the filters out and get everything disposed of and everything ready to go, that was about $16,000 a year. But for this particular customer, they have 5 booths, right? So that becomes substantial savings for them. And then that's like $80,000 right there, just based on the filter usage and the changeout labor. Now, I'd like to mention that our filter, that W5100 filter, was twice the cost of what they were paying for that 1-inch high loft polyester. So we doubled the price of their filter, but we ran so much longer in production, right, that we made that valuable to the end user. And then not only did we cut down on that cost, but we also reduced them on energy costs because honestly the booth never really had to speed up. It ran at the setting that was set to for the majority of the time. And then the filter disposal costs, which can become very expensive, and especially if they're spraying some type of hazardous coating where they can't just dispose of it in the landfill. So that is a great success story that we can play off of, right? And this next slide is just some images of the filtration after that trial. So you'll see to the left and the right, that was a filter that ran for the 16 hours, the 2 shifts, 40 gallons sprayed in the booth, and that's what the filter looked like. Nowhere close to being loaded. We only pulled them out because that's when their current filtration was wiped out and completely done. Honestly, it was probably done before then, but they just tried to get through the time. So you can see in that middle image, you'll see the current filtration far to the left. And then we run what is called our RP3300 right there next to it in the blue. The W50 is the orange. The W51 is the red. That top picture is actually the W52 after 7 days. So that filter ran for 7 days before it needed to be pulled out. The end user chose to go with the lower time, the 5-day, so that he could set his change out intervals, every Monday morning or every Friday afternoon, however it worked out for them. And it wouldn't be staggering because of the 7 days, which if you do the math on that, it would have saved them about $110,000, I believe, overall. So one thing that I wanted to point out about depth loading, also these pictures do a good job of it. If you notice the top of the filtration where they're all laid there together, you notice how tight all the paper is, right? The W50 and the 51 especially, you can see it looks like it's open at all. But if you look at when we started taking on coating, you see how that filter expanded and opened up. And that is a great characteristics of the paper, slit paper. As it begins to load and it's capturing that overspray, it begins to open. And as it opens, it just creates itself more area to catch more overspray without going down into the polyester and face loading out that polyester, okay? So that was a success story. There is a couple of things that I wanted to go over with you on when it comes to new products that we have. We have the filter lock technology that we've created. It's a track system that the filter goes into. It can be installed on all 4 sides of the filter we use a tool to install it. It can convert any booth that has something to fasten the track to. You just need something behind the track to fasten it to. It's about 3/4 inches wide, and the filter goes down into it. The benefit to that technology is that it creates a completely encapsulated blanket. Blankets are faster to change for end users, right? They're back into production faster, and we can also minimize the amount of exposure we have around filtration, where say that maybe a pad didn't get installed correctly. The filter lock with a blanket can eliminate any potential area for bypass, where all the air that goes through the exhaust filtration is going to go, through the exhaust fan is going to go through the filtration. There is some literature and things like that on our website that we kind of talked about with the different charts. We actually have some information on kind of like, hey, this is how many layers of paper are in this model and how many layers of polyester and things like that to help you maybe understand a little difference between the different models of filters. And then we also have a filter lock installation video that we did with our own inside salesperson, Shelly Brown, who had zero experience with this or even how to run a screw gun. So this was the very first time she'd ever put a screw gun in her hand, and we just showed her installing the track so that it could be demonstrated. It's a very simple process and a solution. So at this time, I have done my webinar and I'm open for questions.
All righty, Trey, thank you so much. So anyway, as we mentioned earlier, any questions you have, please type it in now. On your control bar, there is a tab that says questions. Please feel free to type in any questions you may have. In the meantime, I'll mention that I'll come to the last slide of this when we're done. After we're done with the questions, we'll show you a list of webinars, upcoming new webinars that we've posted. That'll be going out tomorrow to all of our distribution network. So there'll be a lot of new topics that you might be able to sign up for. Also, too, is Trey had mentioned that filter lock video that he talked about, Shelly showing how to install the filter lock. That is on our YouTube page, as Trey noted there, as well as all these videos that we're doing. We're going to be posting to the YouTube channel as well. Also, one more thing I wanted to mention is that we're going to, when this webinar is over, you'll receive a short little webinar. Please take time to fill it out and let us know if there's some other topics you might be interested in for future webinars, as well as to tell us how we did on these upcoming, on each of these webinars. I don't see any questions right now, Trey, so it looks like you may have snuck out of this one without any questions. We had a lot in our earlier session, our 11 o'clock session this morning. Trey, would you mind maybe while we're waiting and see if we have any questions, if you wouldn't mind forwarding to the next slide? This is just a who to call list. We mentioned working with your different distributors or end users to try and understand, any of the Colmet products. Here's a list of the regional sales manager, as well as you see Trey over there on the left. Trey also mentioned Brittany. Brittany is the inside salesperson for the filtration product line. So if you have any questions, you can go to either of those individuals as well as your RSMs. And then on your next one there, Trey, if you wouldn't mind going to the next slide, please. The slide here is, we're showing here on a couple of our earlier sessions, we had people asking about, where do you do a request for quote when we were talking about our session on spray booth sizing. So we brought up here, this is just a screenshot from the Colmet website, and the quote request is there. You can type in and answer all the different questions that ask you, and then it goes directly to our inside sales team to give you a quote. On the right side of this slide, it shows you the YouTube channel, Colmet's YouTube channel, and this is where we're posting all the webinars, and you can see the video there for Shelly. Trey, if you wouldn't mind, one last slide, please scoot to the next slide. And then this is the slide. This will go out tomorrow. This is the new webinars. We have one more webinar scheduled this week which is the NFPA and OSHA requirements for spray booth design. That's this week. And then the 4 sessions on the right, those are all new ones, new sessions that we're listing. One of them is, of course, the marketing and sales tools that I'll go through just to kind of talk about the YouTube channel and the website as well. So that's all I had. It doesn't look like we have any questions, Trey. So I just want to thank everybody for attending today and for your time here. If you have any questions, you can always email us at marketing@colmetsb.com. Trey, is there anything you want to add?
No, ma'am. I appreciate everybody's time. Sorry I went so long.
Oh, wait, there is one question, Trey. Sorry.
Okay.
Is there a form to request filter trials? So if they have anyone interested, Trey, do you have any kind of process they have to go through?
Well, I mean, there's really no specific form. Just, shoot me an email or give me a phone call, and, I'll kind of work through it that way. The way we kind of handle trials is depending on the size of it, it's how involved that we get. But, if you have the filters in stock or something like that, we can pull them out of your stock. We'll credit you for the filters that we use, or maybe we have to ship you something special for that one. So that's fine. Just shoot me or Brittany, an email or give us a phone call, and we'll work through it that way.
Oh, thank you, Trey. Well, if we don't have any other questions, so again, thank you, and this will end our webinar. Appreciate your time.